Well, we have another question here, question 7. The question says, determine f prime of x from the first principles if it is given that f of x equal to 4 minus 7x. Well, I'm gonna write the question over here, question 7.1. So we're looking for f prime of x, this time from the first principle, okay? So from the first principle, this means that the derivative f prime of x is given by the limits, okay, of f of x plus h minus f of x all over h, where h approaches 0, okay? Now, I always prefer to solve this separately, okay? This is what I'm gonna do. I'm gonna write here f of x plus h, okay? X plus h. So knowing that f plus x plus h simply means wherever you have x, substitute by x plus h. So because f was initially given by x squared plus 2, over here I am going to write instead of, okay, I'm gonna write like x squared plus 2. So over here I'm gonna write x plus h, okay? Now I'm going to solve this, okay? So I'm going to simplify this, extend this. So this one is not x squared plus h squared, okay? Here we must write x plus h times x plus h plus 2. So we will do then x times x, x times h, and then h times x, and then h times h. And then this will be equal to x squared plus xh plus xh plus h squared plus 2. So that's f of x plus h. Okay, and then we have also f of x. That was initially given by x squared plus 2. So I prefer to write like this, so I can just fill in. We can do now, work out the numerator of this derivative, okay, of this fraction first. Let's do that. So I'm gonna do minus here. Over here I can just complete the missing side with the missing places by zeros. Okay, I'm working out f of x plus h minus f of x. F of x plus h here minus f of x. So now we can solve this. We simplify x squared minus x squared, and then 2 minus 2 falls. And then the difference here, that is f of x plus h minus f of x. This is equal to xh plus xh here is just, okay, we have xh plus x plus 0. Actually, xh minus 0, it's xh, and xh minus 0 is going to be xh. The two makes like 2xh plus h squared. Okay, now we can work out the fraction now, meaning we divide by h. So I'm going to divide both sides by h. So I'm going to say here, I'm going to do here over h, okay, over h. So this will be I'm going to take h as a common, h for the common factor. So that's going to be like 2x plus h over h, like that. And then we can simplify this, h, and then we have left with 2x plus h. Then we can put in the limit. Okay, so the limit over here, both sides. I'm going to place in the limit. So the limit h approaching 0 of what? F of x plus h minus f of x over h equal to the limit h approaching 0 of 2x plus h. Now, when h approaches 0, it means we're going to substitute h by 0. Wherever we see h, we're going to substitute h by 0, okay? So if I sub in h by 0, I don't need to write the limit anymore. So the answer is just 2x, okay? So here, the answer is just, so this means f prime of x equal to 2x. That's the derivative from the first principle. Now, that was question 7.1. Now we can do 7.2. The question says that determine dx over dx if y equal to 4x plus 2 over x. Well, we're going to solve. Okay, let me just move my board this way. We have like 7.2. We're looking for dy dx. Okay. If y is given by 4x plus 2 over x. Now, I am going to write the same, I prefer to rewrite the same function in a different way, because sometimes functions like this, it's tough, a bit difficult to differentiate it unless you have like knowledge of higher grades derivative, okay, techniques. But otherwise, for grade 12, I think it's going to be better if we transform the function, okay? So instead of me writing y equal to 4x plus 2 over x, I can write this y equal to 4x plus 2x to the negative 1, okay? So I can write like that, and then let's now differentiate the function. Okay, I do that because the exponent, one of the exponent rule says that if you have like a to the negative m, maybe let me write it this way, a to the negative m equal to 1 over a to the m. And then those laws of exponents are useful from left to right as well as from right to left. Like I have like this form of the fraction, I can write it as 2x to the power of negative 1. Okay, I had this form, I write it into this form. So in case someone is not seeing it clear, remember like this part here, 2 over x is like 2 times 1 over x. So applying, doing 1 over x as, okay, and then 1 over x has, this x has an exponent of 1, you see? So it's like 1 over a to the power of m. So this can be written as a to the negative m. So this is the part, okay? Now, we can differentiate this function. Now it's going to be easier to differentiate this by following this rule for differentiation. You know, when you differentiate the polynomial, we do the derivative of each term of the polynomial. So it's like it's given by ax to the power of n. Derivative, this is like n times a times x to the power of n minus 1. Okay, so I'm going to differentiate that. Y here the exponent is 1, so this is what I'm going to write. Dy dx 4x derivative. Over here my a is 4 and then my n is just 1. So using this formula, I will write 1 times 4 times x to the power of 1 minus 1, okay, plus, and then over here my a is 2 and then my n is negative 1. Following this formula, this will be negative 1 times 2, okay, times x to the power of negative 1 minus 1. Now, the derivative dy dx will then become 4 x to the power of 0. Over here is just 1, okay, and then x to the power of, excuse me, yeah, x to the power of 1 minus 1 is just x to the power of 0, and x to the power of 0 is 1. So 4 times 1 is 4. So I prefer to write 4. And then here it's going to be a plus, actually minus, because negative 1 times 2 makes negative. So that makes negative 2x to the power of negative 2. So this can be rewritten as dy dx will be equal to 4 minus 2 over x to the power of 2 if I decide to write it back following this formula, okay? Negative exponents, a to the negative m will be 1 over a to the m, so 2 to the negative 2x, 2x to the negative 2, x to the power of negative 2 can be written like this. Thank you. That was question 7.2. And now the next question is question 7.2 points, I guess, yeah, 2.2. That was 7.2.1, now 7.2.2. We have like y equal to 4, the cube roots of x plus 3x cubed to the power of 2. Okay. Now I'm gonna write it here. Or let me just write it over here. Seven plus 2. So we need to find dy dx. Okay, if y is equal to 4 cube roots of x, okay, plus 3 x cubed to the power of 2. Now, again, we're going to transform this function because it's also going to be easier for us to differentiate the way it is. Okay, let's transform the radical signs in the exponential form. So this will become like dy dx will be okay. Before even talking about dy dx, let's first deal with y. So y will be like the cube root of x. There is a law of exponent that says the nth root of a to the power of m. This is just a to the m over n. Okay, so over here the exponent is just 1, so we can just write 4, okay, x to the power of 1 over 3, okay, plus, and then another law of exponent says a b to the power of n. This is just a to the n, b to the n, okay? So this would be like 3 squared, and then x 3 times 2. Okay, this power of 2 will be on the 3 and also on that. Basically, it is this way, x cubed to the power of 2. Okay, but now another law of exponent says that a to the m all to the n is just a m n. Now this makes y equal to 4x to the 1 over 3 plus 9x to the power of 6. Okay, now we can work out dy dx equal to the derivative here will be like I'm going to differentiate this term and then differentiate this other term following the same formula used here. So this will be like a third, okay, times 4 times x to the third minus 1 plus 6 times 9 times x to the power of 6 minus 1. And then that makes dy dx equal to, that makes what, 4 over 3 x to the negative 2 over 3 plus 54 x to the 5. You understand? Now we can, I think now they can allow you leave your answer in this form. Okay, you can leave it like that, or you can write it with a positive exponent by using the law of exponents that we use here. When you move this the denominator and then use again this law, if you need to write it in a radical sign. Okay, so I think we can, okay, you can write it this way, or you can also say dy dx equal to 4 over, you can write 4 over 3. Okay, it can be, let's start with the denominator. I can write 3 cube root of x squared, okay, under 4 plus 54 x to the power 5. You can write this way, leave it this way, or you can also write this other way. Okay. And then the following question is question 7.3. Let's see what they say. What the question says. Well, we have another question here, question 7.3. The question says that if G is linear function with G of 1 equal 5 and the G of 3 equal to 2, determine the equation of G in the form y equal to. Well, remember it is said that G is a linear function. So you know that linear function is of the form, I can do it over here. Linear form is of the form, let me write here 7.3. It is of the form like y equal to mx plus c, okay? So m is the gradient of the function. Now, you know that m is also equal to the derivative of f of x, okay? So y is just f of x, okay? So I'm going to write here f of x. So now m is just the derivative of f of x. Now here it is say that g of 1 equal 5, and it is also say that the derivative of g at the point x is equal to 3 equal to 2. Now, what does it mean? If g of 1 equal to 5, it means that the point 1, 5 lies on the straight line here, on this line. So we have like a point 1, 5, which is point. The point 1, 5 is a point on the straight line, okay? And then the gradient here, m, is just equal to 2 because the gradient for the straight line is constant regardless of the point, because it's a straight line, okay? It's always constant. So the gradient here is going to be 2. M here will be just equal to 2. So either the point equal to 3 or point equal to 4 or whatever point it is, because it's a linear function. Linear functions are straight lines and the gradients are constant. Now, now that we have this point, okay, we can write the line like, you know, f of x is a straight line, so it is of the form y equal to mx plus c, right? So now we can sub in the points, this point 1, 5, okay, this point in the equation and then the gradient as well. So if I sub in the points 5 for y and then 1 for x, and then okay, this is equal to 2 for the gradient, and then plus c. Okay, we can work out c. If I move 2 times 1 is just 2. It's gonna be like 5 minus 2 equal to c. Okay, and then therefore c equal to 3. Therefore, we can say the straight line is given by 2x plus 3. Okay, thank you.